Hello students, welcome you to this video. In today's class, we are going to study something about polynomials. Already you know that. So how we name the polynomial? One is based on the number of terms, right? If there is only one term, we call it as monomial. Two terms, binomial. Three terms, trinomial. More than three terms, normally we call it as what? Polynomial, right? Number of terms. Then based on the degree also, it has special names, right? If the degree is 1, just that one I am going to give first. Degree and name of the polynomial. If the degree is 1, you know it is what? Linear. It is a linear equation. If the degree is 2, familiar one, it is a quadratic, right? Quadratic polynomial. If the degree is 3, cubic. So up to that I think you know. Linear, quadratic, cubic. Then if the degree is 4, that we call it as quartic. Quartic polynomial if the degree is 4. If the degree is 5, at least up to 5 you study quintic. Quintic. Okay. So linear, quadratic, cubic, quartic, degree 4. Quintic, degree 5. Then division algorithm. In 10th standard you would have studied, right? In numbers you studied. Suppose you divide a number p by some number, say r, you divide L by M. You are getting a quotient and you are getting a remainder. Then this L is equal to QM, right? You multiply these two plus remainder plus R. And the remainder can be 0, 0 less than or equal to R, less than M because we are dividing by M. So the remainder must be less than M. But same thing in polynomial. Suppose if we have two polynomials, f of x and g of x. Same thing. F of x, you divide by what? G of x. You will get a quotient, I'm taking it as q of x, and you get a remainder r of x. So here also same thing you can say f of x is equal to, and how they are related, f of x is equal to, you multiply these two, then add this one, okay? So what can you write? Q of x into g of x, q of x into g of x, plus r of x. And the remainder, earlier we said no, it can be 0 or less than m. But here the degree of r of x. Okay, so the degree of r of x. Degree of r of x must be less than degree of g of x. So degree of the remainder will be less than what? Degree of g of x. So that you remember. Then remainder theorem, most of things what you study, already every video I'm telling you, it's a basic algebra. So algebra you studied, every result we recall so that it will be useful to you. When you go for some competitive exams, it will be useful. Otherwise in the lower class you study, you forget everything, right? So it's a chance for you to recall everything. Remainder theorem. You study remainder theorem and factor theorem, right? If the remainder is 0, we say it's a factor, right? What is remainder theorem? I'm not going to give the statement at all, just we see what it is. Say f of x is a polynomial. F of x is a polynomial. So you want to divide by x minus a. When you divide by x minus a, what is the remainder? Remainder is equal to f of a. Because we divide by x minus a, the remainder is f of a. If we divide by x plus 2, what's the remainder? F of minus 2, right? You put x plus 2 equal to 0, so x equal to what? Minus 2, okay? Then if that f of minus 2 is 0, if f of minus 2 is 0, then you can say x equal to minus 2 is a root. X equal to minus 2 is a 0, right? Then which one is a factor? Bring that minus 2 to the left side. You can say x plus 2 is a factor. So this also remember. When f of minus 2 equal to 0, you say that is the remainder is 0. So you can say x plus 2 is a factor. Okay, so that's all about remainder theorem and factor theorem. And in number system we study there are some imaginary numbers, right? So which are not real, unreal number. Discriminant is less than 0. When you draw the graph, it won't touch x-axis, it won't intersect x-axis, right? So I think I want to give you some more information about that unreal numbers, or we call it as complex numbers. But when you go for 12th standard, one full chapter is there about that complex numbers. Okay, so just I want to give you some information. So root of a negative number, right? Root of a negative number is not defined. Root of a negative number. That number is, we call it as what? Imaginary number, right? So here we assign a value. Root of -1 is an imaginary number. For imaginary, the first letter is what? I. So we take root of -1 as I. Root of -1 as I. Now listen here. Root of -25 can be written as root of, you split into 2, 25 into -1. Whenever root comes, you write plus or minus. 25 square root is 5. -1 square root is I. -1 square root is I. So your answer is plus or minus 5i. So you must know from here how to write it directly. So root is there, plus or minus. 25 root 5. Minus is there, so you attach one I. That's all. Okay. So can you say what is the root of -64? Minus is there, so you write, sorry, root is there, so write plus or minus. 64 square root 8. Minus is there, so you put one I. Can you say root of -8? Yes. First you see the root. Root is there, so what do you put? Plus or minus. 8. Square root of 8 is 2 root 2, right? Minus is there, so I. What is root of 100? Plus or minus 10 I? No. Why? Because there is no minus, right? If minus is there, you write what? I also. Okay. So root of -9. What is your answer? Plus or minus 3i, right? Plus or minus 3i. Hope you understood something about the real numbers, right? Sorry, imaginary numbers. Okay, now we move on to the next exercise, 2.6. Listen. Find the zeros of the polynomial function. Find the zeros of the polynomial function. So one function is given here, f of x equal to 4x square minus 25. They asked to find the zeros. So already I said the difference between zeros and roots. For an equation, what is, when you solve, what you get? That are called roots. And for a polynomial, you equate with 0. The answer is what you get, that are called what? Zeros. Only name difference only, the values will be same. So to find zeros of f of x, to find zeros of f of x, what do you do? Put f of x equal to 0. Put f of x equal to 0. So what is fx here? 4x square minus 25 equal to 0. Very simple calculation. 4x square is equal to 25. X square is equal to 25 by 4. So x is equal to, when you take square root of 25 by 4. So since square root is there, you write plus or minus. 25 square root 5. 4 square root is 2. Don't put any I here because there is no negative sign. Okay. So that's your answer. Now listen, x equal to -2 is one root of this polynomial. Sorry, one equation is given, right? You can bring that 22 to the left side. So what is given here? X cube minus x square minus 17x minus 22 is equal to 0. One equation given. X minus 2 is a root. It is given x minus 2 is a root. X minus 2 is a root. That means it exactly divides. Find the other root. See, this is a cubic equation, right? Degree is 3. So it's a cubic equation. So it must have 3 roots. One of the root, you know, it is x equal to -2. It is not irrational root. You know, irrational roots occur in pair. Suppose if they say minus root 2 is a root, immediately you can say plus root 2 is also a root. So it is not minus root, it is only 2. Don't say -2 is a root, so plus 2 is a root. No. That is only in the case of what? Irrational number. Okay. So here x minus 2 is a root. So another root is, sorry, x equal to -2 is a root. So you can say x minus 2. x equal to minus 2 is the root, right? X equal to minus 2 is the root. So what can you say? X plus 2 is a factor. To find the other factor, there are two different methods. Please listen. One method is the given equation. Okay, the given equation you write here, divide it by long division, usual division, x plus 2, you divide by x plus 2, definitely the remainder will be 0 because x plus 2 is a factor, right? You get some quotient, that quotient you equate with 0 and solve it, you will get two answers. That is one method. Or another method, it is a cubic equation, so very easily you can use synthetic division. That also you studied in 10th standard, right? So synthetic division, long division method, and there is one more method. By guessing you can find. Okay, in some other some I'll teach that method also. Okay, so here what we do, we go for the easiest method. Which one? Long division or synthetic division? Synthetic division is very easy, right? So let's go for synthetic division. So coefficients you see, if any term is missing, you put 0. Sign also you take. X cube coefficient is 1, x square minus 1, x minus 17, constant is 22. Just you draw lines like this. Now x equal to minus 2. So you write here minus 2. X plus 2 is a factor, means you write minus 2 here. And always in this place you write what? 0. Add it 1 plus 0, 1. 1 into minus 2. 1 into minus 2, you have to multiply these two, okay? So 1 into minus 2, it is minus 2. Add it, minus 3. Now minus 3 into minus 2. Minus 3 into minus 2, plus 6. Add it, you get minus 11. Now minus 11 into minus 2. Minus into minus plus 11, 2s are 22. If you add, you get 0. You must get 0 because that one gives the remainder, right? Since it's a factor, remainder must be 0. So the other factor, what you get? Other factor is, this is constant, this is x coefficient, this is x square coefficient. So you are getting x square, 1x square minus 3x minus 11. This is the other factor. Now we have to find the zeros of that. So equate with 0. X square minus 3x minus 11 equal to 0, and you can solve it. Sum is minus 3, product is minus 11. You cannot factorize it. So either you go for formula method or completing the square method. Okay, so formula method you can go through. Formula you know, so A equal to 1 here, B equal to minus 3, C equal to minus 11. Quadratic formula. So x equal to, what's the formula? Minus B plus or minus root of B square minus 4AC divided by 2A. So that is minus B. B value minus 3. So minus B means plus 3. Plus or minus root of B square minus 3 square 9 minus 4 into A into C value minus 11 divided by 2A, 2 into 1. So that is 3 plus or minus root of 9 minus into minus is plus 44, right? Divided by 2 into 1, 2. So you are getting 3 plus or minus root 53 divided by 2. So what the question they asked? Find the other roots. If the question is solved, you write all the three answers, right? Here the question is find the other roots of the equation. So therefore, other roots are. So these are the other two roots. Okay, you split and write. So 3 plus root 53 by 2 and 3 minus root 53 by 2. So hope you understood this. Now let's move on to the next question. Find the real roots of. Read the question very carefully. They didn't ask find the roots. Find the real roots. So there, if there is some imaginary roots, don't write in the final answer. You write only the real roots. So degree is 4. So you are supposed to get 4 answers, right? So listen here. What is given here? X raised to 4 equal to 16. Bring it to the left side. X raised to 4 minus 16 equal to 0. You can write it as x square the whole square minus 4 square equal to 0. A square minus b square. You can write it as a plus b into a minus b. This is our a. X square a plus b into a minus b equal to 0. Again you can factorize the second one, or you do one thing, separately equate with 0. So x square plus 4 equal to 0. Another one, x square minus 4 equal to 0. So here x square is equal to, take plus 4 to the right side, you get minus 4. So x is equal to root of minus 4. So x equal to, can you tell me the answer for this? Root is there, plus or minus. Square root of 4 is 2. Minus is there, so I, right? So which is not real. Which is not real, or you say which is imaginary. So when you write the final answer, don't write that one, okay? Now we try to solve the other one, x square minus 4, 0. So x square is equal to plus 4. So therefore x is equal to root of 4, right? Root of 4. So when root comes, you write plus or minus. 4 root is 2. So both the roots are real, right? So final answer. So because the question is find the real roots. So you write the conclusion like this. Therefore, real roots are plus 2 and minus 2. Okay, so these are the two real roots. Degree 4, so you are supposed to get 4 answers. Yes, we got all the 4, but 2 of them are imaginary, not real. So when you write the final answer, don't write that. Okay, now look at the next question. It's a very simple one. Solve. So one thing you can expand and simplify, right? A plus b the whole square, you can do that. Or this is, look here, something square minus something square, right? So this is of the type a square minus b square. So you can factorize directly. You take this part as a and this part as b. So a square minus b square, you can write it as a plus b. This is our a plus b, the second one. A plus b into a minus b, a 2x plus 1 minus, so bracket is important, minus of 3x plus 2 equal to 0. So the first one become 2x plus 1 plus 3x plus 2. Second one do carefully because minus is there, no? So 2x plus 1, that minus is for both. So minus 3x minus 2 equal to 0. So here you get 2x plus 3x is what? 5x plus 3 into 2x minus 3x. What is that? Minus x. 1 minus 2 minus 1 equal to 0. So two possibilities. 5x plus 3 equal to 0 or minus x minus 1 equal to 0. So 5x equal to minus 3 and x is equal to minus 3 by 5. And the second one, minus x equal to 1. Change the sign, x equal to minus 1. So just asked to find the solution. So solution, x equal to, what you get? Minus 3 by 5 and what? X is equal to minus 1. X is equal to minus 1. Okay, so these are the two answers. Okay, now let's move on to the next question. So that exercise over. Few example sums I'll help you because there are few sums you need some help. Find a quadratic polynomial. Quadratic only. Find a quadratic polynomial f of x such that f of 0 is 1. F of 0 is 1. What's the meaning of that? F of 0 is 1. Wherever x comes, you put 0 and your answer will be 1, right? That's the meaning f of 0 is equal to 1. So wherever x comes, you have to put 0. So f of 0 is 1. Second condition, f of minus 2 is 0. F of minus 2 is 0 and another one f of 1 equal to 0. So in two cases, this sum can be done in two ways, but one method is a very simple method. I'm going to teach in that way because of these zeros. Otherwise, what do you do now? Quadratic polynomial. So we take the quadratic polynomial f of x they named. So f of x equal to ax square plus bx plus c. Take it as equation number 1. Apply the conditions one by one. F of 0 equal to 1. What do you do? Wherever x comes, you put 0. And f of x value 1. So 1 equal to, for x you put 0. So a into 0 plus b into 0 plus c. So you are getting c equal to 1. Apply the second condition. What is the second condition? F of minus 2 equal to 0. What's the meaning? Wherever x comes, you put minus 2 and your answer will be 0. So equation 1 becomes f of x. It is 0 is equal to x you put minus 2. So minus 2 square 4a. X minus 2 into b minus 2b plus c value 1, right? So 4a minus 2b equal, take that plus 1 to the other side, it become minus 1, equation number 2. Now apply the last condition, f of 1 equal to 0. What's the meaning? For x you put 1 and your answer is 0. Equation 1 becomes 0 is equal to, because f of x you put 0. For a you put, for x you put 1. So 1 square into A, so it is 1A plus 1 into B plus C value 1. So A plus B is equal to, take this 1 to the other side, minus 1. Okay. So these are the two equations. From these two equations you can solve very easily, right? So what you can do, so second equation write as it is, 4A minus 2B equal to minus 1. Third equation you multiply by 2. So you will get 2A plus 2B equal to minus 2. Just add it. So when you add 4A plus 2A, it is what, 6A, minus 2B plus 2B cancel, you are getting minus 3. So A equal to minus 3 by 6, you are getting A equal to minus 1 by 2. To find B value, make use of equation number 3. Equation 3 says A plus B equal to minus 1, right? A plus B is equal to minus 1. So A value minus 1 by 2 plus B equal to minus 1. So B equal to minus 1 plus half. So B is also minus half. So all the values you got it. A equal to minus 1 by 2. B equal to minus 1 by 2. And C value you got, I think 1, right? Yes, C equal to 1. All these values you substitute in the first equation. So what's the first equation? Ax square plus bx plus c. So substitute the first one, you get the quadratic polynomial. Ax square, a value minus 1 by 2, ax square plus bx, b value minus 1 by 2x plus c value 1. Okay, this is the general method for any question. But this question, if you want, you can do in another way. This method you can do, there's nothing wrong in that. You can do this. And most assumptions you can do only in this way. But this particular question, in two cases, the right side value is 0. So you know f of, suppose say f of 2 minus 2 is 0. What's the meaning? The remainder is 0, right? So it's a factor. So that concept also you can use it. So I'll teach that also. So it will be useful to you. Okay, now let us see another method. See, this is what we have, right? F of 0 is 1, f of minus 2 is 0, f of 1 equal to 0, right? So what we do, so you look these two. This is a special case for this question, okay, because the right side values are 0. F of minus 2, 0. F of minus 2 equals 0 means, what can you say? X plus 2 is a factor. Because equal to 0, right? F of 1 equals 0, see the last one. So what can you say? X minus 1 is a factor. So you can say the function can be, there are two factors, you got it. X plus 2 is a factor, X minus 1 is a factor. Some constant would have come, right? Because, see, minus 2 is a root and 1 is a root means, when we say, suppose if we have 7 into x plus 2 into x minus 1 equal to 0, what do you say? 7 cannot be 0. Either x plus 2 0 or x minus 1 0. So x equal to minus 2 and x equal to plus 1. Instead of 7, it can be any number, right? So there can be some number. So that is why we are taking what? K. Okay, there is some number k. Now let us find that k value what it is. Okay, so for that we make use of, actually this is our answer. To find k, make use of this condition. So since f of 0 is 1, so now we apply that. For x you put 0 and fx value 1. So you get 1 equal to, for x you put 0, so k into 0 plus 2, 2, 0 minus 1 minus 1. So 1 equal to minus 2k. Change the sign, 2k equal to minus 1, k equal to minus 1 by 2. So substitute in the first equation, f of x equal to k value minus 1 by 2 into x plus 2 into x minus 1, right? So this is what you are getting. Now listen here, so can be simplified, minus 1 by 2 into, so multiply term by term, x into x square minus 1x plus 2x minus 2. Like terms you simplify, minus 1 by 2 into x square plus x minus 2. If you want, multiply every term by minus 1 by 2, you will get the answer what you got earlier. Minus 1 by 2 into x square, so minus 1 by 2 x square minus 1 by 2x. Next minus into minus plus 1 by 2 into 2. 2 get cancel 1. Okay, this is the answer already got here also, right? So the same answer can be done in different ways. For the examination, you see the situation. If the values are zeros in the right side, you can use this method also. Okay, now listen to this example sum. Construct a cubic polynomial. Previous one quadratic, now it is what? Cubic polynomial having zeros at cubic polynomial. So 3 zeros should be there. Here x equal to 2 by 5 is 1 0. Then x equal to 1 plus root 3 is a 0. Then some other information also given, right? Okay, now 3 zeros we need. One is 2 by 5. Then another one is 1 plus root 3. You know, 1 plus root 3 is an irrational one, right? Irrational roots occur in conjugate pair. So you know the other zero is 1 minus root 3. So now with these zeros, you can find the factors. So here x equal to 2 by 5, right? So cross multiply 5x is equal to 2. Bring it to the left side. 5x minus 2 is a factor. In the second case, there are two zeros, right? These are the two zeros. To find the factor, quadratic polynomial, right? X square minus sum of the roots in the x plus product. So you find the sum and product. Sum, add it 1 plus root 3 plus 1 minus root 3. So plus root 3 minus root 3 cancel. 1 plus 1 is 2. Sum. Product you find out. Multiply 1 plus root 3 into 1 minus root 3. So a square 1 minus root 3 square 3, you are getting minus 2. So here the factor is, so what factor you are getting? X square minus sum of the roots, that is 2 into x, plus product of the roots, that is also what? Minus 2. So now you can write the cubic polynomial. Therefore, cubic polynomial is, see, f of x equal to, so here they given some names, yes, f of only they used. Already got one factor, 5x minus 2. So 5x minus 2, and the other factor is x square minus 2x minus 2. In addition to that, a constant may come. So this is your answer. We have to find that k value. For that, you make use of the condition f of 0 equal to minus 8. Given f of 0 equal to minus 8. What's the meaning? Wherever x comes, you put 0 and your answer is minus 8. So instead of f of x, you write minus 8. Minus 8 equal to k into x is 0. So 5 into 0, first term 0, 0 minus 2. So minus 2. In the second bracket, x is 0. So first, second term becomes 0, you get only minus 2, right? So minus 8 equal to minus into minus plus 4k. So cancel 4 table, minus 2 equal to k. So k value minus 2. K value minus 2. Substitute in the first equation. So first equation become f of x equal to k value minus 2, right? K value minus 2. So minus 2 into 5x minus 2 into x square minus 2x minus 2. Now since they asked as a polynomial, so you have to expand and write. So fx equal to minus 2 into, now you multiply term by term, by 5x you multiply everything, 5x cube minus 5 2s are 10x square minus 5 2s are 10x. Now by that minus 2 you multiply, minus 2x square minus into minus plus 4x minus into minus plus 4. Now like terms you simplify, then finally you multiply by minus 2, right? X cube term only 1. X square you can see 2 terms, minus 12x square minus 10x plus 4x minus 6x, and finally you have a plus 4. Now multiply every term by this minus 2, so minus 10x cube minus into minus plus 24x square plus 12x minus 8, right? So this is the required cubic polynomial. It's a very important question, so practice well. Now we go for another question. Listen. Prove that AP plus Q equal to 0. Prove that AP plus Q equal to 0 if f of x is divisible by g of x. F of x is divisible by g of x. Divisible means the remainder will be 0. You will get some quotient, right? It is exactly divisible. So the remainder must be 0. So that concept you can use here, and let us see what you get here. So now what can you say? Since f of x is divisible by g of x, the remainder equal to 0. So this concept we are going to use. To find remainder, you cannot use the direct method, remainder theorem you cannot use because it is not, g of x is not a linear one. It's a quadratic, you can't factorize it, there are some unknowns, so you can't do that. So better you go for long division method. So f of x, so you have to do very carefully, f of x is x cube, x square is not there, so I'm writing plus 0 x square, then x term minus 3px plus 2q, you divide by g of x. What is g of x? The quadratic one, x square plus 2ax plus a square. Okay, you can do very easily, but you need to practice it. Okay. So now listen, x cube by x square. The first quotient, first term is x. By that x you multiply every term, x into x square plus 2ax square plus a square x. Now we have to subtract it, so change the sign. The first one is x square, x into x square, it should be x cube, right? Minus, minus. So first one cancel. 0 x square, leave it, you are getting minus 2a x square. Then minus 3px minus a square x, so I'm taking minus x outside, so what you get, 3p plus a square. Actually, minus 3px minus a square x after changing the sign. In both the terms, minus is there, x is also there. I'm taking minus x outside. So what's the remaining? 3p plus a square because minus you're taking out. Okay, hope you understood. And the last one is plus what? 2q. Okay, this is what you are getting. Now for the next term, so here see what you have, minus 2ax square, right? So minus 2ax square divided by this one, x square. So x square cancel, minus 2a. So right here minus 2a, this is a very important step. Next two lines, listen very carefully. By this minus 2a, multiply everything, minus 2a x square, plus into minus is minus 2 2s are 4a square x, 4a square x, then minus 2a cube, right? 2a cube. Now the next step, you find the remainder, right? So change the sign, the minus become plus, and this minus become plus, and this minus become plus. First term get cancelled. Now listen very carefully. See what you have, I'm going to write. X alone I'm taking outside. So 3p minus is there, minus 3p plus a square. That is minus is outside, so minus 3p minus a square. You can take like that. And here after changing the sign, it is plus 4a square. And the last one, 2q plus 2a square. We change the sign, right? So this is the remainder actually you are getting, right? But so the remainder is equal to 0, meaning, so you simplify this, there is a like term, right? So minus 3p plus 3a square equal to 0. But before that you write a step, then you write equate with 0 into x plus, there you cannot simplify, 2q plus 2a square a cube is equal to 0. So now both the sides equating the coefficients of x and constants, equating the coefficients of x and constants. So first equate the x coefficients. Here x coefficient is this one. What is that? Minus 3p plus 3a square equal to the right side, it is 0. No x term. So x coefficient is what? 0. And constants. Here this is a constant, right? Independent of x. 2q plus 2a cube equal to the right side, the constant is 0. So from these two, see that you are getting the result. See what they asked to prove? AP plus q equal to 0. AP plus q equal to 0. AP plus q equal to 0. Let us see how to do this. In the first one, you can divide by 3. 3 is common, right? Minus p plus a square equal to 0. So a square is equal to p. Okay, leave it. The second one, you divide by 2. See what you get? Q plus a cube equal to 0. In the answer, we want q. AP we want, so I want only 1a. So q plus a cube, you split a into a square equal to 0. That is q plus a into a square. A square can be replaced by what? P equals 0. So you are getting AP plus Q equal to 0. Okay, so you need practice it. So then only can do that. Like that, few more sums. We'll continue in the next class.